Bayes' theorem, and then I'm going to go over the homework problems in the Resnick homework number 5, Bayes' theorem part 1, so you can see they're worked out in great detail on the solution key that's posted on the Canvas site, but you can see me actually work some of these problems out. Now let me start off first of all. Bayes' theorem was first, well, we might not want to say first proved, but the person who's received credit for first proving Bayes' theorem was a British theologian, Bayes, a bishop actually, or at least a high ranking in the Episcopal Church in Britain, who dabbled in probability. Now I'm going to write out Bayes' theorem in its basic form, and please note that I will never ask you to memorize Bayes' theorem for the purposes of this class, nor will I ask you to figure out how it's proven, though Resnick does a very nice job of showing how it's proven in his text. But Bayes' theorem basically states that the probability of P given Q equals the probability of P times the probability of Q given P. All of that over the probability of P times the probability of Q given P plus the probability of not P times the probability of Q given not P. Okay, now, once again, like I tell you, you do not need to memorize this particular rule. You will be given it on any test you're asked to do in this particular class. But let me sort of tell you its basic components. The probability of P of and in and of itself is known as the prior probability of P. The probability of Q given P is the likelihood that Q will obtain, assuming that P is true, and the probability of Q given not P is the likelihood that Q would obtain given that P is false. And this entire expression under the divisor line is the total probability of the of Q. The prior probability of P times the likelihood of Q given P plus the probability of not P times the likelihood of Q given not P. All of this combined in this way gives you a way of computing the probability of P given Q. In other words, it tells you how to calculate the posterior probability of P in light of Q. And you can thereby, once you've gathered the evidence of Q, you can readjust your assignment, the original assignment or the prior probability of P, into this new probability of P in light of the evidence Q. So what we're going to see in the second part of the homework is how Bayes' theorem basically can serve as a way of computing probabilities of hypotheses in light of new evidence. A crucially important thing to understand if you're going to use probabilities to assess risk and to combine them with things like monetary values or utilities in business decision making. You want to make sure that those estimates of probability are as accurate as possible. And what Bayes' theorem gives you a formula for is how to gather evidence and reassess the probability of a hypothesis from your initial assignment to a new assignment in light of the evidence that you gathered for Q. That's what makes it such a powerful theorem for improving our assignment of probabilities in light of the gathering of evidence, as we'll see after we get a basic understanding of how it works.